So now we're going to use the triple integral to find one more mass in the rectangular coordinate system. We're going to find the mass of the portion of the cylinder, which is 9y squared plus 4z squared equals 36. Now you'll notice that's elliptical because the coefficients in front of the y and the z are not the same. And we want it to lie between the planes x plus z equals 6 and x minus 2z equals 4. So let's look at this in Maple real quick. All right, so I've drawn it two ways. I drew it with plot 3D right there. So it's kind of that section of the cylinder right there. And I also drew it with implicit plot 3D. I don't know which is better, but there you have it. So it's an ellipse, and then we're cutting off sections of that ellipse, right? Okay, so now we got to try to draw this thing. So let's see here. Now the good news is that we know that it's hitting at an ellipse. So we know that it's at 3 here, and we know it's at 2 here. So we can draw that ellipse, more or less. And that's the cylinder we're working in. So we could draw its companion back here, and then another one up in the front. So we can make like a tube, an elliptical tube. Okay, so there's our ellipse. So you draw this ellipse 3 times, or excuse me, our elliptical cylinder. So you draw this ellipse, 3 times, and you have it. Okay, so now we want to hack into it with 2 separate planes. So you have one plane kind of coming around like that, and then you have another one kind of going forward like that. And we want the section that's between the two, as hard as that is to grasp, right? We want the piece that's between those 2 planes that are coming through at diagonals. All of it. Okay, well, that's tricky. So we got to figure out which one's in front and which one's in back, first of all, because that will help us figure out what we're doing here. So let's look here. So when we have these cylinders, this one in the back, that, oh, excuse me, this is in the front, because that's the positive x-axis right here. See, that's x right here. So the positive x-axis has this red one in front. All right, so the red one was x plus z equals 6. It's the second one right here, because that goes with the second color. So that's x plus z equals 6. The one in the back is the 2x minus, 2x minus z equals -8. I actually apparently changed that one. There we go. So apparently I changed it in the page, so I'll change it again. So that's okay. Here we go. Let's look at it here. So we're going to change this to x minus 2z equals -6. As I recall, the one that was originally written doesn't actually have a solution, so that's why we rewrote it. All right, so we'll want to think about stacking pillars inside here that'll go from here to here, right? So that's where our pillar is going to be, inside that zone. So we'll have to ponder that. We also need to think about the region of integration, which in this case is really easy because this is an ellipse. So we know the region of integration comes from this. So this is the surface over here. So for the region, all right, I'll draw it here this time. So it's going to be an ellipse because we would let x equal 0, right? So at x equals 0, which is the yz plane, or see, zy, there we go, zy plane, right? We would come across like this. All right, so if you let y be 0, then 4z squared would be equal to 36, which means z squared is 9, so z is 3. So this is at 3 and -3 here for z. And y, if you let the z be 0, 9y squared would be 36, so y squared would be 4, so that's -2 and 2. All right, so that's our region of integration right here, R. Okie dokie. So we have some things to think about. We have lots of work ahead of us. All right, so the mass is equal to the triple integral over the solid of the density function. And then we have to ponder which way we're going to go, but I'll just say dv for right now. Okay, so mass is equal to triple integral, and this is all the work, right? The work is setting this up. Once we've set it up, the integration is usually not too terrible, um, although we can always make an exception. All right, so our density function's easy. Delta is 4, so that's easy because it was given right here. Right, there's delta. Delta. All right, so delta, and then now which way are we going to go? Well, this is obviously going to go for x first, right? Because the stacking the columns in from the front to the back, that's dx orientation. So we're going to do dx first. Let me do dx in orange here. And then we're going to have to go for either dy dz or dz dy. It kind of doesn't make any difference. It's just a question of which way would you rather solve. So usually students, when faced with a choice, would rather do vertical, so that's fine. And if we did vertical, that would be dz dy. Okay. And that's going to take some doing. We'll be back for that. That's going to take some work. All right, but that's our plan. So we're going to go dz next and dy. Okay, y is the easiest piece because y goes from -2 to 2, right? It's constants, so that's easy. -2 to 2. X is actually a little bit easy as well because x is going to go from the back to the front, right? So what was the back right here? What was this plane? This was the one that actually was written wrong in the first place. So this back plane, right? That's the back. Actually, let me write it up here. So if I solve this for x, I would get x equals 2z take away 6. So there we go. That's the back. So x equals 2z take away 6. And again, you don't have to write the x equals. I'm just putting it in there to remind myself that that's the variable I'm doing first. All right, now what about the front? Well, the front is this other one, right? So the front would be solving this for x equals 6 take away z. All right, 6 take away z. No harm, no foul, right? So x is easy, y is easy. Z is not so easy because we have to come up with the equation for the ellipse on the top and on the bottom. So we are going to have to solve this equation for z. So let's solve it for z. So 4z squared equals 36 take away 9y squared. So z squared is 36 take away 9y squared over 4. So z is plus or minus the square root of 36 minus 9y squared over 4. And that square root goes all the way to the bottom. Although I will say the square root of 4 is 2. So we could do that if we wanted. We could say plus or minus the square root 36 minus 9y squared over 2, right? Because the square root of 4 is 2. All right, so that means we're going from the negative square root of 36 minus 9y squared over 2 to the positive square root of 36 minus 9y squared over 2. That's going to be fun. Good times. Okay, so we're going to start with integrating this with respect to x. So that'll be 4x, and x is going to go from this value to this value, right? So that's actually relatively easy. So we're going to have the integral from -2 to 2. And then we're going to have this integral from, I'm just going to write negative square root dot 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 to positive square root dot dot dot. I don't want to write all of that over again. I know it's terrible. All right, and then this is 4x. And x is going to go from 2z take away 6 to 6 take away z. And then we have a dz and a dy. All right, so then we're going to have another, well, I shouldn't do this. All right, I'm writing it. 36 minus 9y squared over 2, negative 36 minus 9y squared over 2. All right. Ugh. All right, so now I'm going to put 6 minus z in here and 2z minus 6. And the 4 actually can kind of come out. It doesn't really have much to anything to do in there. So you can pull it out in front or you can leave it in there. It's not going to hurt anything. And then we have this lovely integral from negative square root of 36 minus 9y squared over 2 to positive square root of 36 minus 9y squared over 2. And then this is going to be 4 times, and then it's 6 take away z, right? That comes in front, minus, and then 2z take away 6, right? And 4 is times the whole thing, and then dz dy. You can't use your trick because y and x are all over the place, so you're stuck having to do all this integration. Okay, so this is going to simplify. Let's think. 6 take away a negative 6 is 12, right? So that's 12z, and then negative z minus 2 more z is minus 3z. So this is 12 minus 3z right here. So if we multiplied 4 times the whole thing, it'd be 48 minus 12z. So we could do that, or we could bring the 4 out. I mean, it doesn't really make any difference. So all right, we're about to integrate though. So let me just write this whole thing. This is 48 take away 12z, right? Okay, so then I'm going to write one more integral. So this is the integral from negative 2 to 2. This is the integral from negative square root of 36 minus 9y squared over 2 to positive square root of 36 minus 9y squared over 2. And then I'm going to integrate, well actually, I'm going to write this one more time. So this is going to be 48 minus 12z. Here, I'm just going to write this like this. I'll put it in here when I do the integrand. So 48 take away 12z, dz, dy. And again, we have to go in this order because we chose this order, and it wouldn't be any different if we did what dy dz. But we have to do z first because there's y's in here, so we need them. Y is the one with the constants. So this is the integral from negative 2 to 2. And then this would be 48z minus 6z squared, right? Because we would add 1 to the power. And then that's taking that from negative square root of 36 minus 9y squared over 2 to positive square root of 36 minus 9y squared over 2 dy. And we're almost there because we're just going to make Maple do the last step. But first we're going to substitute. So this is negative 2 to 2. 48 times this guy. The square root of 36 minus 9y squared over 2 minus 6. Now if we square this, it becomes 36 minus 9y squared over 4. That's the entire front, minus, and then 48 times negative, so negative 48 square root of 36 minus 9y squared over 2, minus 6 times, and then we square this one. When you square a negative, it turns it positive. So it'll be the square, or it should be 36. Sorry, I just realized I have an extra parentheses in there for no reason, so hold on. There we go. 36 minus 9y squared over 4. This whole thing has to go in, and dy is the end. And of course we are going to make Maple do that. We are never in a million years going to do that integral. No, 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 no. All right, so even though I was supposed to do it by hand, here's the original integral. Integrating 4 from x equals 2z minus 6 to 6 minus z. Z equals negative square root to positive square root, and y equals negative 2 to 2. And I come up with 288 pi, which is about 904.778 or 779. So then I checked my next step. After I had integrated, I came up with 48 minus 12z. So that was my integral, and so I said take that integral from z equals this to this and y equals that to that. And that still worked out. And then I have that last step that I wasn't sure about because it was really ugly, but I've got it in there and I typed it carefully, and sure enough I come up with the same answer. So this is a way you can use Maple to check your answers even if you have to do them, quote, by hand, unquote. All right, so going back, let's see. So with maple, it was 288 pi or 904.78, and the units would be grams because the density was in grams per centimeters cubed. So these would be in grams.